So let's backtrack a little bit and go into slide 32. And we're going to re-export our neighborhood adjustment sheet. So if we remember, we first started out with our mate. So just kind of as a review, the first thing we started out with was what? We had this matrix. And what was the matter with this matrix? Anybody remember? So when we first started this, like our last two sessions, anybody remember? Our end goal was to get that affinity matrix. And the rows, we had what? Starting in H, what did we have? Adams, Allen, blah, blah, blah. What are all those guys?
Those are all the offers.
Well, those are all those are going to be the customers. And then going down column A, we had what?
Offer numbers.
Those are kind of the offer numbers. For this to work, like remember when we did our friends, we had the people and the people both on the row and down the vertical. So what we have to do is we had to go from matrix over into similarity, where we put the customers across the top row, and we also had to put the customers down the leftmost column. Because right now we have offers down the vertical and customers across the row. So we went into the similarity thing and we said, all right, we put everybody in here. We did this formula to go look at the similarity matrix. We did the sum product, and then we had all these stubs out there, and then we said, and then we got down to we could either use the R neighborhood or the K nearest neighbor, and we decided we're gonna go with the R neighborhood, and that's when we did that whole percentile. So we said, here's our edge counts, and then we did the 80th percentile, and we said anything above a 0.5 was going to be in that percentile. So then we went over into the R neighborhood adjust, and we said, all right, if something over here is greater than 0.5, we're going to list it as a 1. If not, we're going to keep it as a 0. So based on this, we can now take this sheet over into Gephi. Everything else we did from here going to the right, we didn't need to do, and we did it, but Gephi does it for us. So Gephi is kind of like that black box that does everything for us. So if you guys didn't have this, if you don't have your CSV, the Gephi import, go into the R neighborhood adjust and go into File, Save As, Browse, and then go to the desktop, and then you're going to save as type, and you're going to come down here to CSV, probably like 14, 15 down here, and let's call this guy Gephi import. Gephi import. Okay, and it's going to give us the warning saying, hey, the CSVs only support exporting one file, and that's okay. And it's going to say, hey, if you do this, the CSV doesn't have all the formatting and everything else. And this is fine, we know this. And we said, we want to say yes to that. All right, so now we have our Gephi import saved as a CSV. If we go to the desktop, so we can right click down here and go to the desktop and go into Gephi now. And launching Gephi here. And then we're going to open, and Gephi will open that graph file. And we're just going to point to our desktop and to the Gephi import. And the good news is this new version of Gephi, you don't have to change it from commas into semicolons. So we're lucky, we're fortunate. We click next, and then we're going to say intervals, this is fine. And we're going to click finish. So right here we have the two errors. We said, hey, the one record all the way over in column 101, it had a blank at the top. That was where we summed up those columns. And the row 102 had a missing piece. That's okay. We didn't want to include those anyways, so we could ignore these errors. This is fine. Graph type. What kind of graph type do we have? Does anybody remember? Mixed, directed, or undirected? Undirected, right? So we said undirected. Okay, so we have our nodes and edges, and we're going to put that in here. Let me see something. Actually, let me just double check. I thought it was directed. Yeah, directed, undirected. Yep, undirected is correct. Okay, so we click on OK. And then we have 99 nodes and 429 edges because they're bidirectional here. And then we had to do what? So this new version of GetFi doesn't recognize people with zeros, and we know that Parker actually had a 0. So does anybody remember what we had to do? So we go into Data Laboratory, good, and we're going to add a node here. So we add a node, and then our label is going to be Parker. Parker. Okay, and there we go. And now when we go into our overview, we're going to have our map, and then you guys are going to go into Layout, Force Atlas, and you're just going to hit Run for a split second because Parker flies out there pretty quick. So you just hit Run and stop, and you'll see like Parker like quickly exiting. Okay, so now all you do is just grab that little dot Parker, and you can bring him in closer to the fold, and now you can zoom out. Okay, so we kind of see our clumps. We see this big clump down here. We see this big clump up here, and then we see these other random clumps in here. And if we wanted to, we can put on our, I'm gonna make this bigger. Okay, and if you want to turn on the labels, if you turn that T on right here, that brings us our labels. We could shrink down our labels if we wanted the label size right here, if we wanted to. And does anybody remember how we got the modularities, how we figured out what clusters everybody was supposed to be in here? Anybody remember that? So a hint, we went over into the statistics section over on the right-hand side. Now, does anybody remember what we clicked over here on the network overviews? Modularity, good, Ryan, good. So we're gonna click on modularity and we're gonna run. And then you could, this is already weighted, so you could uncheck the weights and click on OK. And then you're either gonna get 4 or 5. So if you got 4, you can just click close and you can run it again until you get something that has. There you go. So it might take a couple times and you get to 6. So for write down this number 2, that little modularity number, if you guys have a pen, just quickly write that down. 0.545 is mine. So we want to make sure once we take this back into Excel and do our magic that we have it. All right, so once you have your diagram, you can come over into nodes, come over to ranking. We can go into color, and then I like to do ones that have like the most color, like this bottom one, and we can hit apply. And now we have our different colors here. And if you want to, you can even dial down the names if you want to a little bit. Okay. And then if you come over here to preview, and we should be able to hit labels and then hit refresh. Okay, and then here's our lines right here. Actually, if you guys want, you could turn the labels off. That might be a little bit better. refresh. Okay, so now you can kind of pictorially see all your different communities here. That's kind of cool. So with this, if you look, you can see, depending on the number of communities you have, you should see that many color different dots. So I have like this light tan, and then I kind of have like this like light orange, that's 2. And then I have light blue, light green, dark red, and dark blue. So that gives you my 6 different clusters right there. So you pictorially see your clusters. And now if you want, you can come over here and you can do the export down at the bottom. And then save that to your desktop, and then you can call it like a PNG, and just call it like cluster or something like that. GFI cluster, something like that. GFI cluster. And now if you come in to show your desktop, now you've got a pretty picture to hang on your refrigerator. Okay, so you do that in Paint or whatever. And there you go. So you'll post that, so submit that picture along with your chapter 7 stuff. All right, coolio. All right, so with this then, we're going to go back into GFI. And then let's go into Data Laboratory. And let's do our table export. So we're going to export the table. And when you export the table for the name, call this GFI export. And you want to click the options on the bottom right here. And then just have either ID or label checked, one or the other, and uncheck the other one. And then have interval unchecked. So either ID or label checked, the other one unchecked, and then interval unchecked. Then we'll click on OK, and then we'll hit save. And then now what you can do is go to your desktop, and then
Wait, what are the options? Label and interval or unchecked?
Label and interview are unchecked, or interval or unchecked, correct. Let's see. Yeah, and this gets funky, this whole. So when you do that, so when you go to the, when you do the export table, do this. This is kind of funky. Well, I saved mine into documents. All right. So I meant to save it on desktop. Okay, so here I have the GFI export. And then you're going to click this guy. And then if you come down, you're going to see that Parker has 0. So change. Oh, I actually had label 2. So if you gooned up like I did, do this. I'm just going to take out all columns except for ID or label, one of the 2, and modularity class. Okay, and this bottom one is going to be Parker. That says 0. Okay, and what we're going to want to do is grab A and B and sort and filter this. So you can do sort A to Z. And it's smart enough to know to sort the leftmost column. And now once you have this, you're going to copy this and then go back over into Communities GFI in your other sheet and just paste it in there. And A1, just paste. Okay, how's everybody doing? Good?
You paste it over it?
Yeah, you can just paste it over it. Yeah, that's fine. Okay, how's everybody doing? Everybody's tracking, nobody's not tracking. Everybody's good. Awesome. Good job, guys. Seriously, good job. All right, so now what we want to do, we'll pick up, now we could go back into PowerPoint here. We probably did about 3 slides worth of work here. Let's see where we're at. Okay, so we're down to, okay, so in C2, we're going to add the score. We're going to add the label score. So in your communities get by in C1, let's add score here. And then you're going to copy this formula. And if we look at this, we're essentially going to take the sum product of B2 to B101. And then if that value is equal to B2, then we're going to say 1, otherwise 0, and then we're going to multiply that by the transpose B2. Okay, so if the B2, so if the value in B2 equals B2, then we're going to give it a 1, otherwise 0. So we'll use that 1 times the transpose in scores over here to add all those scores up together. So in C2, I'm going to grab this formula. And notice that because we're transposing, it means what? Anybody? We have a transpose in there. It's going to force it into an array function. So make sure when you paste it in here, you do Control-Shift-Enter. Okay, and that's going to give us our score. So essentially what we're doing is we're looking at if the score in atoms, if B2 to B101 equals B2, then we put that 1 in there. And then we're grabbing the scores, and then we're just going to add those across. And now we can autofill down. And then in E1, let's type the word modularity.
If we have different values for modularity class, will we have the same?
Yeah, it should. It doesn't. Yeah, your modularity class is going to be different than my modularity class.
I noticed that the score was, most of our scores were the same, but our modularity class.
Yeah, that's fine. It'll all come out in a wash here.
Okay.
And then in E1, type modularity. And then you're going to add this formula. It's basically going to take the sum of all these items, and it's going to divide it by the total number, by that 858 number. And if all goes well, this number should equal the modularity number that I said to write down a couple minutes ago. Put that in there, and then go. So it might be they have those funky quotes in there, so you might have to go back in and retype the single dashes. Dash. Let's see, what did I have reference? Oh, okay, so this is what happened. If you go back into, so when we created our CSVs, it renamed the tab. So copy up here where it says our neighborhood, up in from the formula bar, you're going to copy this. And then double click on where it says GEFI imports. Hit escape, and now hit GEFI import, and then rename. And then make that the our neighborhood adjust. And now our community's GEFI should be happy. Everybody get that? And if all went well, but whatever that number was I said to copy down, should be the same number. That's kind of like that, Jen. Okay, everybody's good? Did that computer die, Anthony?
Windows just supports that.
That did, okay. Cool. All right, so everybody's tracking, everybody's good now? Cool. Awesome, awesome. All right, so let's go into 37. So the next thing we're going to do now is we're going to go over into the top deals by cluster, and we're going to make a copy of the sheet. So we're going to right click, move or copy, then make sure you move it to the end and make sure you click the button that says create a copy. And then you're going to rename this guy where it says cluster at the end. You're just going to tag on GEFI, no spaces, and take out the 2. And after you do that, you're going to go into column A1, and you're going to sort the offers from smallest to largest, put that guy back in order. And then from here in editing, you're going to go into sort and filter, and you're going to take filter off. And then now, here we had 0, 1, 2, 3, but assuming you had 6 clusters, you're going to add 4 and 5. If you only had 5 clusters, just add 4. So up here at the top where it says 0 to 3, in L1 add 4, and M1 add 5 if you had 6 clusters. If all you had is 5 clusters, just put 4 in L1. Okay. And then now we need to go update our formula in H2. If you look at H2 right now, it's going to currently reflect communities, but now all of our deals are going to be in what? In GEFI communities, or communities GEFI. So we need to go update that formula to reflect GEFI, and it's going to be in column, we go over here to the right. It's going to be communities GEFI, and then also instead of the B column over there, or I'm sorry, if you go look at this formula now, it's saying communities D2. We actually want to pull our values from communities GEFI, and where's our communities at? In column D or which column? What do you guys think? Where's the modularity class column? D, right? Okay, so we're essentially just going to update that with this formula. So it's going to look in GEFI's community. If it equals a top deal cluster at the top, then it's going to add up all the scores across the matrix going across. And then because the column, you have B2 to B101 and the matrix, because that's vertical and the matrix is horizontal, you have to transpose the matrix to make them both columns. Because you did that, now you have to put it in as an array. So let's go back into top deals by cluster GEFI, and we're going to throw in this formula into H2. And you're going to do the Control-Shift-Enter. And now you just drag that across and then autofill it down. No, it's not autofilling. If necessary, you just autofill and drag it manually. Okay. And guess what we're going to do now? I'm sorry?
I'm getting a reference.
Make sure you do the Control-Shift-Enter. It's going to be an array. All right, hold on. When we did the top deals by cluster before, remember we did that electric boogaloo? We kind of split. So we went to 4 and we said, it doesn't really get us much going to 8, but it could have been if we did 6. But doing the model we did with the Bison clustering, we can only go from 4 to 8. We couldn't go from 4 to 5 or 4 to 6. So actually, the GAFI not only is it easier, but it looks to be, at least in my personal opinion, maybe even a little bit more accurate. Mine seem to be tighter, better, or your guys is tighter and better. Like the way it identifies them, like, you know, it's really prominent. To me, it was like really prominent that on this first one, for me, it was very prominent that this was low quantity, you know, 6, bang. The second one, clearly French. Okay, so clearly my first 5 are French right here. Okay. My third column, let's see, mine I'm getting Pinot Noir. So the first 4 Pinot Noir. Okay. My fourth one, I'm getting bubbles. I've got Spumante, Champagne, Prosecco, Champagne, Champagne, Champagne. So to me, these look like they're even tighter, better clusters. Okay, so if I look at this one, all big, large quantities in here. My fourth one, my fifth one. And then my sixth one here is, that one's not so formed all that well, but yeah, so that one's kind of a little loosey on this last one. Oh, because this last one is what? It's loosey, there's no association, but I just have 1s and all 0s. So who's that? Just Parker out by himself. Okay. So pretty cool stuff, man, isn't it? So we did these different models. So we basically looked at the wine problem, and instead of doing the Euclidean and the K means and the K medians clustering, we did a whole new way using this network graph. So not only was this network graph more accurate, but we're able to generate pictures. Pictures are 1,000 words. So when you start looking at these pictures and showing people, like, what is this? Like, you know, you can show your boss, like, hey, pictorially, here's what this looks like. Let me open it up with Paint. So open up with Paint. So this is pretty cool to show people. So remember when I talked about the whole like airlines, when you see like those nodes on the airline pictures, like you'll see a city and like all the lines where they fly to. Guess what that is? Network graph. You guys can now do network graphs. Pretty insane, crazy, right? Awesome. Look at you guys, you're data analysts. All right, so let's now move on to this. Let's go into artificial intelligence with regression. We're going to go into artificial intelligence with regression. So now what we're going to do is going to grab a whole bunch of data on what people bought, and we're going to try to figure out, are people pregnant or not? So if you could tell a person's pregnant, if you're Target, what can you do?
Look at what they buy.
I'm sorry?
Look at what they buy.
Look at what they buy, but what can you do to help make sure they buy stuff at your store?
Send them
advertisements to them in their email, send them deals, mail offerings, Craco stuff, everything else, all that baby stuff, diaper genie stuff, all that stuff. So now you can target those guys, and now they're going to start buying stuff at your store, hopefully. So if you start doing that, now you start driving revenue to your company's making money now. You're adding value as a data analyst. Pretty cool stuff. So grab these charts and save them to your stick or whatever, and then let's now roll into chapter number 8. Look at us go. All right, so we're going to go into chapter 8. We're going to pull down the PowerPoint. All right. And then we're going to pull down the Excel file. So it'll be Retail Mart. All right. And in the first couple of slides, I'll be here and then I'll shift over into Excel. We don't have too much, so most of those other chapters, we have like maybe like 9 or 10 slides that talk about things before we get into Excel. This one's not that much, so we'll quickly cover those. All right, so this whole chapter then is about us doing regression. So this has like been around for a long time. So we can look at this as supervised artificial intelligence. Anytime we say supervised, what does that mean to you guys? What do you think? If we say supervised versus unsupervised?
Train model.
We're going to train the model first, right? So we're going to take the model, we're going to train the model, and then we're going to get test data. So the first couple pages here are going to be talking about how we get data from our customers. So we're going to develop predictions using regression. And then once we do this, we're going to actually look at things like R-squared, F-test, and T-test to see if our, which of these coefficients matters more than others. And then we're going to apply this to this receiver operator curve. And then we're also going to look at this from a logistics regression model as well and look at the differences between them. So as we said, the supervised artificial intelligence algorithm, we're going to feed it historical data. That's going to create our model. And then from there, we're going to feed it into a new set of test data. So we're going to take this past data into the rules that we use. So regression, been around a long time, like since the 1900s. So even though it's old, it's pretty tried and true. So lots of rigor compared to the newer AI intelligence techniques. But as we saw on the network graph, even though that's only a couple years old, like maybe 5 to 10 years old, network graph is actually pretty cool stuff. So how are we going to get our customers' data? How are we going to get our customers' data? Purchase. How are we going to get their purchases?
Loyalty cards.
I'm sorry?
Loyalty cards.
Loyalty cards, right? So when you go to Vons, what's Vons say? Go type in your card. They'll give you a little bit of money, right? So they'll give you a little bit of discount, but what are they doing? They're grabbing all your data. They're data mining you. Why do all these stores give out? Have you noticed that Kohl's has their own credit card, and JCPenney's and Sears and Nordstrom's? So if you buy something on their credit card, guess what? They're mining your data. They know what you bought. They own the data. You're using their card. So these are all ways that people could start sucking in your data. If you buy online, they obviously have all of your data. So what we want to do then is we want to pull out these relevant predictors. So we'll make this list of maybe like 16 or 17 items. And these are going to be called features. And then we're basically going to look at these to see if they're going to be good indicators of somebody that's pregnant. And we can look at things like, are they male versus female? Are they buying prenatal vitamins? Are they buying ginger ale? So you can buy ginger ale because you're nauseous. Maybe you're buying ginger ale mix in a drink. So most of us aren't drinking when we're pregnant. Okay. So, and then if you get enough of these past purchases, then you could, you're hoping that you're going to be able to classify these persons as either pregnant or not pregnant. So as we look at this, if you start looking at people that are pregnant, about 6% of households are pregnant at any given time. So 94% aren't pregnant. So, so what we're going to do is we're going to grab examples of pregnant purchasers, and we're going to grab examples of non-pregnant purchasers. And then how can we tell if somebody's pregnant? How can you tell? What do you think? What are something that people buy that are pregnant or after they just had a kid?
Diapers, baby food.
Diapers. So do they buy diapers once? They buy diapers multiple times. What about if they start buying diapers in small, then diapers in medium, and diapers in large? All right. So they've been buying diapers for like, a year or two, and the sizes start getting bigger. Probably a good indication that they have a little kid in the house. So that person, they look at, it's like, all right, whatever this person bought before, if they look, I'm like, all right, when they start buying diapers, right? So now they know what somebody bought that's pregnant. What did they buy before they were pregnant? Did they buy ciggies? Did they buy booze? Did they buy whatever? So because you have to try to determine what a person that's non-pregnant buys versus a person that's pregnant or just had a kid purchases. So that's how we're going to look at this data to try to guess who's pregnant and who's not. When we train our model, we're actually going to oversample. We're going to get, so even though only 6% of households are pregnant, we're going to train our model with 500 persons that are pregnant, 500 households that are pregnant, and 500 houses that aren't pregnant. So if we base this sampling on the number of households pregnant, instead of having 500 pregnant, 500 not pregnant, how many would we have if we just had 6%? Anybody? 60. Like 60, so we'd have like 60 pregnant and then 940 not pregnant. When we do our model, we're going to oversample this. Like I said, we're going to do 500, 500. Even though this is going to introduce bias, since we're not computing probabilities in our regression, it doesn't matter. So even though we're oversampling, it does not matter for us doing our regression. So remember, anything you kind of see here in these red blocks, these are all probably good things to know for the assignment quiz. Okay. So let's open up our data here and let's go take a look at what we've got. All right, so we're going to get into this whole concept of categorical versus quantitative data. So if you look at the training data, what do we see in the first couple of columns here? So what's column A have in here? So it kind of has gender, right? What about from C going from C beyond? What does that have? I'm sorry? Well, it's going to have purchase, but as far as like, how do we know if somebody purchased something in like C going forward?
So 1 or 0.
A 1 or 0. So 1 would be they bought it, a 0 would be they didn't. So if you look at column C over, these are going to be considered quantity items, okay? If you look at column A and column B, these are currently categorical values, meaning a person is male or female. The first thing we want to do is we're going to want to create these things called dummy values so that we convert our male and female into 1s and 0s in appropriate columns. We're going to convert house, apartment, or PO box into house or apartment. If it's neither one, we're going to assume that it's a PO box. If we don't see a male or female, we're going to assume we don't know the gender of that person. So if we look at slide number 7, then the first thing we're going to do here is we're going to we want to unhide our training data with dummy variables. So I kind of already helped us out a little bit to get us started. We're going to unhide, and we're going to do the training data with dummy variables. Okay, so what we want to do is we want to take the M and the F for gender and make that into ones and zeros. We want to do the same thing with address for home and apartments. To do this in A2, let's look at this formula. We're going to say if the training data cell A2 equals M, we're going to say that it's a 1. So we're basically going to say that's a person is male. If in B2, we're going to say in that same cell in training data A2, if we see an F, then that person's going to be female, and we're going to put a 1 there, a 0 if not. Okay? So let's go drop these values in, and we'll do the same thing for home and apartment. So let's grab these values and put these in A2. And then B2. And then in C2. So it kind of makes sense if a person's male, they're not female, right? So if you saw a 1 and a 1, that would kind of be like dirty data. That's another thing you have to be careful of when you start getting this data. And the chapter talks about that. Let me make sure I didn't gloss over that. So let's send these down. So grab A2 over to D2 and autofill that down. Okay, so now we know if person's male or female. Yeah, I think there was a discussion about data in the chapter. So if you guys haven't had a chance to read the chapter, but it's actually maybe like the first 3 or 4 pages. It actually has some good background on classifying data, getting dirty data, and how we account for that. All right, so how's everybody doing here? Everybody's good? Everybody's not good? We're all tracking? Awesome, good. You guys are getting really good at this. This is great. All right, so let's do a sample here. So one of the things we want to do in regression is we have to get these coefficients. So each one of these are going to be considered a coefficient, but we also have to figure out the intercept, where when x is 0, where y is at. So let's just go to throw together a sheet really quick. So hit the plus over here. And you can call this sheet 1, just call it like cats. And then A1, type cats. And then B1, call it sneezing. And then here you're going to put 0, 1. So this is going to represent the number of cats to the probability a person's going to sneeze. And this is the author of the book. So I suspect he doesn't have an affinity towards cats. And then you're going to add, let's see. So you're going to do 3% and then 20%, and then 36%, 45%, 67%, and 80%. Okay. So if we have this data, is there any way that we can predict what the slope of this line is going to be? So remember in math class when we wanted to do slope, what was that formula? Anybody remember?
Y equals x plus b.
Y equals mx plus b, good. Okay, and then to do the slope, we did what? Y2 over y1 divided by x2 over x1, right? Okay, so the cool thing about Excel is it'll actually do this for us, which is pretty cool. So let's highlight our data here from A1 down to B7. And down here in this quick analysis block, click on that guy, and then go into charts, and then do a scatter plot. And then over here in the change chart type, click on that, and just do the first one here, the scatter plot with no line, just the dots. Okay. So if we have these dots here, what Excel Smart to do is it's going to draw a line, and it's going to draw the slope on the line. So as it takes a difference between the line and the dot, it's going to minimize the error in there, and that's going to be what drives the slope on here. So in this, if we click on the plus, this is really cool. We can go into this trend line thing, and let's draw a linear line. So that's the slope of this line. So pictorially this looks good. But what about if we wanted to know what the slope is? So Alex said it's mx plus b. So we said that y is mx plus b. Okay, so how do we know what the m value is, and how do we know what the b value is? So this m is going to be the slope, and what's the b value going to be? So if m, when we say that x is 0, y is going to be equal to what? B, and that's, anybody know what that's called? Y-intercept. The y-intercept, good. Okay. So we can go through all this and put some points in, or under the trend line more options, click on that. And then look at this block down here where it says display equation on chart. Isn't that pretty cool? Okay, and you can click on this guy and go into home and just start making this value bigger. Hit the A. Look at that. Pretty cool. So what's our what's our slope on this line? Okay, it's about 15%. So as you get more cats, there's about a 15% more chance about that you're going to sneeze. And what's the percent that the person's going to sneeze if there's no cats? 3.6. 3.6%. Okay, so we're going to apply this same concept, except right now what we're going to say is instead of the number of cats, we're going to have like 18 different values in here. And we're going to say, is the person pregnant, yes or no? Okay, so that's what this whole chapter is about here. Any questions here? Okay, cool. All right, so let's go back into our chart then. Retail marts. Okay, and we're going to be going on slide number 9. So if we go in and unhide linear model, what I did here is I set up our values over here, like male, female, everything we had before. This is just a copy of the test data. And then we had our training data with the dummy values. And then if you look over to the right, our intercept column, I put all ones in here. So all these are going to be our features or our coefficients. And this is going to be our intercept. So this is going to be what that line intercept is going to be. This value here, this intercept, is going to essentially be the m value, or I'm sorry, the b value here. It's going to be our y-intercept. So doing all this, and you fill in all the intercepts down below, and then we have our pregnant data. If we look down, we're going to see that the first, if we scroll down, if we get down to here into row 507. You're going to see that the 1 stop. So this reflects our 500 that are pregnant, based on the people we think are pregnant, and the 500 we think that are not pregnant. So now what we're going to do is we're going to create our model. Once we have our model, then we're going to apply that to our test set of data. Okay. So again, if we look up here at the top, we have all of our different coefficients. And then we're going to have our coefficient standard error and t-value and our t-test. So we're going to get to these in a second, and that's going to be part of the goodness of our formula. Okay, so in W8, we want to put in this formula right here, and this is going to be the sum product of the B values. Right now, they're all 1, and it's going to be times the value in, so B2 to U2, and it's going to be B8 to U8. So if we put this in W2, and then if we autofill this down, what's going to happen to our formula here? So we're going to copy this, and in W8, we're going to put this formula. Okay. So what happens if we drag this down? So B2 to U2, what happens there? So if we go up and down, what happens to B?
B stays the same.
B stays the same, right? Because we're going vertical. Okay, so that's good. And then what about on the next one as we go? So what about the 2 there? What happens with that 2? It stays the same. So on each one of these rows, what we want to do is we want to take the sum product of those coefficients times all the values in each one of those rows. If we go down one, the B2 to U2 stays the same. What happens to the B8 to U8? What happens to the B if we go up and down? That's going to stay the same, but the 8 goes to a 9. So we keep the B2 to U2 locked in, and each column we go down, we're always going to apply B2 to U2 to each one of these rows. Okay, that's kind of cool. So send this guy on down. Okay, and then this gives us our different intercepts here based on the values that we have. And then let's format the W8 to W1007 as numbers with 2 decimals. How do we do that? So over here so you can right click and do format. I find it easiest if you go up here in home on number group. If you go into general, you can just hit number right here, and that's going to give us our 2 decimals. If we want to add more or less, you could simply just click the add increased decimals or decreased decimals. Okay. Coolio. All right, so let's go on to slide number 10. And what we want to do now is we want to, just like we had that, like that line where we had with the cats, we want to get the difference between the line and the point, and then we're going to square that error. So in this case, it's going to be 1 minus 5, which is going to be minus 4, and if we square that, it's going to be what? 16, right? Good. Awesome, Brian. So let's grab in this formula. We're going to put this in X8. Okay, so 16 as we thought. We're going to autofill this guy down. Okay, and the same thing, let's make this a number with 2 decimal places. And we could see on that fourth one, the linear combination prediction based on us doing the products, and the sums was 3. So if we have 1 minus 3, that's 2, and then it's going to be squared, and that's going to give us 4. So what we want to do then is we want to sum up all of these squares now, and we're going to put that in x1, and that's going to be the sum of squared error. Sum of squared error. So we're essentially going to take the sum of all these values and put that in x1, and that's going to be this formula right here, the sum of x8 through x1007. And you should see 14,780. Okay. And then what do you think? If that is our sum of squared error, we can do solver, and do you think we want to maximize our error or minimize our error? We're going to minimize our error, right? All right, so let's go let's select the x1, and let's go into solver. So data solver. All right, so our objective is going to be x1, and we want to minimize that. And what we want to do is we're going to minimize this by updating the values in B2 to U2. Those are going to be our coefficients that we're multiplying by each row. So when we tweak those values to the right value and minimize this, that's going to be our optimal solution. So that's going to be the values that we change by. So let's grab U2 to B2 for the changing cells. Right, let's add some constraints. So we want to keep this, we want to constrain this, and you can kind of play around with this, but as we do evolutionary, this thing will go forever, and we're trying to bound this. So what we'll start off with is greater than or equal to -1, less than or equal to 1. But you can start playing with the models here to make it larger or make it smaller. But you can be there for a while. But for us, I'm just gonna let you guys know, do greater than -1, less than or equal to 1. So let's add a constraint. And we're going to do B2 to U2. And then I'm just going to scrape this. So I'm going to copy this guy, B2 to U2, just because I'm lazy. And we're going to say this is less than or equal to 1. And then I'm going to add. And then I'm going to paste in that same value instead of having to copy it over again. And we're going to say this is greater than or equal to -1. And we're going to click on OK. And then let's make our unconstrained. We don't want our we want our we will allow our unconstrained variables to be negative in this case. So let's uncheck this box. And what do you guys think? Let's do this as evolutionary, or let's do this as simplex. Can we do this or not do this as simplex? So what's the value that we're looking? So we're changing these cells, but what are we looking at here? The value of x1 is based on what? The sum of the squared error. So if we look at x1 is the sum of what? So x1 we said, so each one of these are squared errors, okay? So we did the pregnancy minus the prediction squared. Evolutionary, right? Because we can't do squares with linear. Linear is just a straight line, and squares are going to be what? Those are going to be those hyperboles, okay? So because we're doing squared here, we cannot use simplex. We actually have to use evolutionary. So let's go in and select this solution. And we're going to make this evolutionary. And then we're going to solve.
Change the time.
You don't have to change the time in this one. It actually works out okay. But good. Way to be thinking, George. So click solve, and let's see what this guy does. Okay, you're going to see it setting up the problem. And we're not over 200 because we only have 3t. So that's like, what, 16, 17, 18 values in here. And you're going to see this thing is going along. But what this is essentially doing is it's going to look at each one of those coefficients up at the top from B2 over to U2, and it's going to adjust each one of those so that as it multiplies them by each row, it's going to come up with the least value. So if you think about all the computations this has to do, it's essentially looking at, it's going to find a value in each value in B2 to U2, so it multiplies it by each row in here, like the zeros and the ones, and comes up with the squared error such that that's minimized. So you can just imagine all the computations this has to do. So it's just insane to start thinking about when you look at this. And here it is. It popped up the solution. Then we click on OK. All right. I got 185. Oh, I don't think I unchecked mine. Let me go into solver. Did anybody? What did everybody else get? 138. Yeah, you should get like 137. Did anybody else get anything like 185?
No, 135.
135, yeah. Okay, so let me see. I've got x1 is minimized, b2 to u2, make unconstrained. Let me solve again. Yeah, 185 is really high, actually. What did you get, Anthony?
Ridiculous. I'm trying to do this myself.
Okay.
Still trying to catch up.
Okay. And what did you get, George?
136.
Okay. Yeah, and just look at that thing down to, I mean, if you look at the trial solutions and just, I mean, just watch it going. It's like insane. But it's just, it just blows me away that this is going through, again, taking each value, like B, and going all the way across, and finding that value so that when you adjust it, as it multiplies it across the sum product of each one of these rows, to get this and do the squared error, we come up with that value. So it's pretty mind-boggling what this can do. So I'm glad Excel is doing it and I'm not doing it by hand. Could you imagine, how long would this take you to do it by hand? I mean, literally the rest of your life. So we said our processor is going how fast? Like 2 billion times. 2 billion times it goes up and down on a cycle every second. It's absolutely insane. Uh-oh, 142. Better. Let me try it one more time. How you doing, Anthony? Getting there, okay. All right, so why don't we end here today? So make sure you grab this, and we'll pick back up on Tuesday.